keeps the flame sort of like, I don't know, in a flame shape coming out the bottom of the nozzle. As you get higher, like climbing a mountain, the atmosphere gets a lot thinner, right? And the thinner atmosphere has less of an effect sort of pushing that flame into the pencil flame coming out of the back of the rocket. And you see what's called plume expansion. The plume starts to expand out the sides. And of course, it's a Falcon 9. It's got 9 engines on the bottom. So instead of just one big nebulous cloud behind the rocket, you actually get sort of discrete little expanding flame plumes coming out the side, outside than one engine in the middle. So the higher and higher you get, the thinner and thinner the atmosphere gets, and the more and more that exhaust plume expands out behind the Falcon 9. You really get to see it there. You get the main engine cutting off, and then all of a sudden, there's some things that you can't see on this camera shot looking down. The rocket does a couple things. You're going to see the upper stage separate. That means the second stage sort of separates from the booster, the parts that's going to come back down to land at the Cape. And the second stage is going to continue going on. Also, behind the camera for a minute, the fairings are going to separate. And those are those protective aeroshell fairings up at the top that protect the payloads while you're down in the thick atmosphere. But once you get up high enough, the atmosphere is thin enough, there's not so much air that you can just get rid of the fairing. Don't want to carry the mass of it anymore, but you don't also have to protect your payloads from the atmosphere. And so what you see here all of a sudden is the booster flipping around. Because this is an RTLS, literally stands for return to launch site, right? It's going back to where it came from. It's not going downrange to a drone ship or anything like that. It's going back to the Cape, to a landing pad, call it LZ. This one's going to LZ1, that's just a couple miles away from where it launched. So here, you see it flip around because right now, it's still ballistically falling away from the launch site. And it needs to turn around if it's going to end up back where it started. So it does this flip. You see these cold gas thrusters sort of spewing out the sides, and that gives it a little bit of force up at the top of the rocket to help flip the rocket around backwards. Once it gets flipped around, it literally did about a 180 there. Once it gets flipped around, it ignites the engines again. Not all of them, just a couple of them. And it does what's called a boost back burn.
Right, you'll see that flat Earth right there? Look at that. Look at that. It's flat. That local moon, sun. Look at that local sun and a flat Earth. Look at that. It is flat right there. No consistent curvature. Oops.
The boost back berm actually keeps it from falling downrange. It stops its progress downrange, and it starts to turn it around so it starts to fall back towards the Cape instead of falling onwards to the ocean, down where the drone ship would normally be if it was a drone ship landing. After the engine stops, you can actually see the grid fins deploy. Up at the top of the Falcon 9, there's 4 grid fins that sort of stick out to the side. They almost look like little flippers, right? The trick is, up high, there's not a lot of atmosphere. So the grid fins don't really have anything to push against. They have air flowing through them, but when there's no air, the grid fins are just sort of out. They become more and more important the lower into the atmosphere that the rocket gets. As you get closer down to sea level, there's